This lesson is on the introduction to logarithms. By the end of this lesson, you should be able to use the rule of inverses to change an exponential function into a logarithm function. In this lesson, you need your calculator again. So exponential functions are of such importance to mathematics that their inverses, functions that reverse their actions or undo, are important themselves. These functions, known as logarithms, we call them logs, will be introduced in this lesson. So the first thing we need to do is the function f of x is 2 to the x. Is shown graphed on the axes below, along with its table of values. So they did it for you. Is the function 1 to 1? Explain your answer. So is y equals 2 to the x an exponential function? Because x is in the exponent. Is it 1 to 1? Yes. Why? Because it passes the horizontal line test and the vertical line test. No x or y value repeats. So if we looked in the table some more, we would find that no x or y value repeats. Based on your answer from part A, what must be true about the inverse? The inverse is also a function. So the original exponential is a function, and so is the inverse, as long as it is 1 to 1. So now they want us to create a table. Well, we already know that these are inverses of each other. We know that in the original, we have x. X becomes y, and y becomes x. The input becomes the output, and the output becomes the input. Okay, so now they say we have to graph it. So let's plot these points. So we're going to go over an eighth and up negative or down -3. We're going to go over a fourth and down -2. We're going to go over a half and down -1. We're going to go over 1 and down 0, over 2 and up 1, over 4 and up 2, over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 3. Oh, it kind of looks like an exponential, but turned differently. And this equation, notice, is symmetric across the line y equals x. So graphically, that's how we can tell their inverses. What would be the first step to find an equation for this inverse algebraically? Well, how do we find inverse algebraically? We switch x and y. So write that step down and stop. So we had y equals 2 to the x. So now we have x equals 2 to the y. Go ahead and pause this video. Make sure you're okay with what we've done so far and read the box at the bottom. So the things I highlighted, the function y equals log base b of x is the name we give the inverse of y equals b to the x. Notice how I said that. Y equals log base b, so little b, and that's called a subscript, of x. For example, y equals log base 2 of x is the inverse of y equals 2 to the x. Based on exercise number 1D, we can write an equivalent exponential equation for each log as follows. Log base b of x is the same as b to the y equals x. So sometimes I call this form ben. Base to some exponent equals a number. So to write ben in log form, we have log base b of n equals e. So this equation, like they said, would be log, my base is 2 because it has the exponent attached, my number is x, and it equals y. So that's how they got the answer. So it is very, 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 very important that you know how to go from exponent form, which I just highlighted, to log form, which I just highlighted. And basically they're formulas. And you need to know where to put what numbers in the formula. So a logarithm is a simple way of saying what power. So in exercise 2, we're going to evaluate the following logarithms. If needed, write an equivalent exponential equation. Do as many as possible without the use of the calculator. So let's see how many we can do without the calculator. So they're telling us in part A to use log base 2 of 8. What does it equal? Well, what does it equal? We don't know. So this is log form. So at the top of the page, I'm going to write my two forms. Ben, base to some exponent equals some number. And then log base b of n equals an exponent. So notice a logarithm is simply a way of saying what power. So a logarithm always equals the power or the exponent. So we know x is our exponent. So what's our base? 2 to the x power equals 8. 2 to the x power equals 8. So 2 times 2 is 4. 4 times 2 is 8. So 2 times 2 times 2 is 8. So x equals 3. Hopefully that one was easy enough for you to do without a calculator. So the next one, log base 4 of 16. We don't know what it equals. So we know the base is 4, the exponent is x, and it equals 16. So 4 to the x equals 16. So what's 4 times 4? 16. So what does x have to equal? What is the exponent? 2. So notice all of these, we're saying the base is 2, it has to equal 8. Well, 2 to the third equals 8. 4 to the second equals 16. Ho ho ho, now we're in fractions. So 6 is our base, raised to our exponent equals our number. So 6 to the x has to equal 1 over 36. Well, we're going to ignore the 1. So 6 to what power is 36? Well, 6 times 6 is 36. So that's 2. Because it's a fraction, it is negative. So x equals negative 2. Next, log base 5 of radical 5 equals, I don't know. So 5 to what power equals radical 5? 5 to the x equals radical 5. Well, I know that radicals can be rewritten as a power of 1/2. Oh, 5 to what power equals 5 to the 1/2? Well, x equals 1/2. Why don't you go ahead and try E through H, and then I will play the video with answers. All right, check your answers. Hope you did well. If you have any questions, just make sure you ask in class. The extension. So now notice we're not looking for the exponents. We're looking for another piece. So when we have a single log equation, or we call this a simple log equation, we want to write it in Ben form. How do you undo a log? You write it as an exponent. So again, 2 to the 4th equals x. Oh, well that's not so hard. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. The next one, 3 to the 2nd equals x. Well again, not so hard. 3 squared is 9. Next two, well I notice, the x is where the base is. Might be a little bit more difficult. So x squared equals 16. Piece of cake. What number squared is 16? X equals 4. And the last one, x to the 1/2 equals 9. Well, what to the 1/2 power, or what number square rooted, equals 9? So x equals 81. Take a minute, maybe pause the video, make sure you're good to go on going between exponent and log form. So to undo an exponent, you use logs. To undo logs, you use an exponent. So the next two require a calculator. So they say if the function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would represent its y-intercept? Well, certain things you need to know about logs. Your base is not ever going to be negative, and it's not ever going to be 0, and it's not ever going to be 1. So it could be a fraction, and it could be greater than 1. So your base has to be greater than 1, and b cannot equal 1. Sorry, it can be greater than 0. I apologize. And it cannot equal 1. Now, this thing inside the parentheses, if you look at the top of your page, this is the n. So your n also has to be greater than 0. Because your answer, if you look above it, are all of our examples, when they're in exponent form, all of our answers are greater than 0. They're not negative, okay? And that goes along with the activity, the what power activity we did in class. So grab your calculators, let's plug it into the graph and see what we get. Now your log button, you should see it above the 10 to the x button. So you have to hit Control 10 to the x. Notice there's a subscript for the base, and in our case it's 2, and we have x plus 8 in parentheses, and outside we have plus 9. Remember from earlier in this unit, the plus 9 means up 9. So hit enter. Interesting. So we need to know our y-intercept. Well, y-intercept is on the y-axis, so I clearly have to go up here. So I'm going to try, I don't know, 50. Oh, a little too high. So I'm going to change my 50 to maybe 20. Okay, it counted by ones. I could look in my table or I could count. I like my table because sometimes counting is hard. Remember, y-intercept, the x is 0. So my answer is 12. So the point was 0, 12 because the y-intercept, x equals 0. So my answer is choice 1, 12. The next one, between which two consecutive integers must log base 3 of 40 lie? So grab your calculator. This time we need a calculator button, or calculator page. You're going to hit the log button again, so Control 10 to the x. Our base is 3, and our number is 40. So 3 to what power would be 40? Well, 3.357762, and this is an irrational number. So log base 3 of 40 equals 3.3577, and I'm going to put ... Now let's think about this. What does 3 to the third equal? 3 times 3 is 9, times 3 is 27. What does 3 to the fourth equal? 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's why 40 is between 27 and 81. So that's why the log of it is 3.3577, blah, blah, blah. So it is between which two consecutive integers? Choice 3, numbers 3 and 4. All right, again, pause the video, quickly read about calculator use and logarithms, and then let's do exercise 5. So notice, when we use logs, if there is no base written, that is base 10. So if you just see the word log, like an example number or exercise number 5, and there's no base written, it must be base 10. So that is called a common log. So if we're looking for the value of this, we know that our base is 10, our exponent is x, and our number is 100. So 10 to what power is 100? So x equals 2. Now you could just plug these in the calculator, yes. But let's use our brains for a little bit. So this one, our base is 10. We're looking for the answer. So 10 to the x equals 1 over 1,000. So 10 to what power is 1,000? 10 times 10 is 100, times 10 is 1,000. So x equals 3. But 3 is 1,000. So to make it 1 over, we make it negative. Last one, 10 is our base. We're looking for our exponent. So 10 to the x equals radical 10. Well, radical 10 or square root of 10 is the same as 10 to the 1/2 power. So x equals 1/2. Well, you've just been introduced to logarithms. Good luck. If you have any questions, ask in class.